Okay, thank you. Good evening, because it's evening in my country, Bosnia and Herzegovina. It's 9 o'clock, and I believe it's 3 o'clock in your country, in your Eastern time zone. So thank you, everybody. This session will be recorded, so if someone doesn't make it right now, he or she can maybe watch and learn something new later when they have a time. So yes, the topic is data breaches, let's say like that, prevention and mitigation. Really interesting and really hot topic, especially in these days, COVID-19 outbreak, where we have a lot of situations, uncontrolled situations that we didn't expect to be happening so quickly and so eventually and so frequently. And in this mixing of different security vectors, data breaches are happening almost every day. They appear every day and before COVID, but now in COVID-19 outbreak, data breaches are more frequent. Yes, hello. Do you hear me? Do you hear me? Do you hear my session? Do you hear me? Okay, I will just continue. Okay, thank you for supporting this event, UNICEF, because this is a noble cause, and I will try to give my best as I can in this situation to support this cause, and I hope my session you will find it useful in your daily work. Also, thank you for our sponsors, because without sponsors, this event, offline or online, virtual or not virtual, are simply is not possible. And also, thank you to all the volunteers and a lot of men's and women's behind the scene, because their hard work is simply doesn't show in the first place, but they are in behind and are making this all possible. Also, I will kindly ask you for your feedback after the session. Also, feedback based on my session. What do you think about it? Do you find it useful or anything else? Speaker feedback, and also please give some event feedback later after this event or this session. Okay, summary. What we will speak about is about data breaches and cybersecurity. This presentation is simply divided in three sections. Introduction part, where I will try to from high level overview, explain what is going on in the space of data breaches. Then in the middle part of the presentation, I will speak about what is missing in all process that actually making possible all this data breach story. And on the end, especially it's a central part of the presentation, I call it handle data with care, where I will try to explain how to prevent and how to mitigate data breach scenarios using SQL Server. Okay, in this introduction part, I have 5 slides. It's a simple high level overview in the space, in the look, in the perspective of the modern environment and the data breaches that are happening everywhere. But before we start, I believe this presentation will be interesting to developers and DBAs and data developers. This top 10 plus 1 best security practices is simply from their perspective. Each person that actually write the code, I don't know, C#, Python, Visual Basic, C++, doesn't matter, should try to implement this at least 10 plus 1 is a bonus. Plus 1 is actually learn continuously. But in this space, if you doesn't follow this practice, you can fall in a trap that your code, your application, your environment become easy target to hackers to anybody with malicious intention. Actually, the one part is data related mostly, and this is handled data with care. Okay, how data breach occur? Simple, there's many scenarios, but in this simple slide, we can start like this. Okay, but important part is that you never underestimate the person, the group, or population that are trying to be malicious to you, to you personally, to you as a business, to you as a company, to you as a group, doesn't matter. Never do underestimate, because we don't know the reasons, we don't know the resources, we don't know the financial cost that other side is ready to sacrifice to make you damage. Okay, the research part is when the individual or group simple try to look the weakness and weakness inside your all environment to spot the weak point, sweet point, and try to exploit. Okay, when they find something that they can use, we are jumping in phase 2, stage attack. In stage attack, the person, the group, are trying to use different vectors of approaching: social engineering, infrastructure weakness, web server weakness, phishing emails. There's a dozen examples how this part can be used. For example, let person A, malicious user, find the open port inside your server. That port is not blocked on your firewall, and it will accept the network command, and it will accept the command from other side. Telnet port, I don't know, SQL Server port, FTP port, remote access. There's a different kind of ports where other party can try to exploit. Also, another scenario, the user can send a phishing email with a payload inside that email, inside the link, and send to the all company emails. I can bet that at least one of the emails will get the click, and the click is enough, because we are all working, let's say, with admin permissions on our own PCs, on our business PCs, and that's enough. That payload is simply delivered to target machine, and payload will try to exfiltrate the other resources inside your environment. Another step is step 3, access to your database, access to your files, access to your emails, you name it. And the final step, the user, the malicious user can't simple copy that file as a Control-X, Control-V to their own PC. They need to try to find different ways to, for example, start HTTP on another port, open the unknown website, try to start FTP telnet session to simply transfer the files, data files, emails, everything that's interesting to them to their own location. And that's how data breaches occur. It's as simple as that. But there's another scenarios like this. Okay, if you are looking from the DB perspective, database, I believe each one of you who actually write the code and dealing with data on daily basis will recognize at least one potential malicious point. For example, backup files. How many of us is copy backup files to USB drives, SD cards, mixing the staging environments, testing environments, production, and simply that backup files are going from A to B, and that's totally out of control. Also, same as data log files. Attach and detach these files to simply recreate environment to where you can do your daily job is also can be used as malicious. Also, oversized DB permissions. What it means? Don't give the user or group the maximum permissions, because simple we are too lazy to click deny, allow, write, for example. we give them SA, we give them security admin, and from that point you are creating the totally new endpoint in security with the possibility that that group or user inherent permission and pass that permission to other users, and you will create a whole bunch of new users inside your DDB that you simply can't control the situation, and so on. And if you watch this pie chart on the right of the slide, data stealing analysis, you will see that in all these scenarios, 90% are hacked. So people from outside of your company, outside of your environments, are easily can hack through one of these attack vectors. 10% is other. What is other? We will see later. Okay, more details. Black data, let's say black data. If you see down below on the left, these are the trends in 4 segments: laptops, DBs, email, and tapes in a timeline. And you will see that, for example, laptops in all these scenarios, we have 47% of attempts, and of that 47%, 25 is success, and the risk is 11%. Okay, let's jump in DB. In all the pool of attempts in one timeline, the 40% is on DB, and the most scary part is that 64% of that attempt are success. And you see the total risk is 84, and you see that this red line is going sky high. What it means? It means that we are using DB. We are speaking about security. We are using encryption policies. There's a lot of security story, a lot of hidden fuzz about this, but the green line is going high sky. So what is going on? Why is that? I will try to explain that later in the presentation, and I believe you will get it on the end. Why in this situation we are speaking about security in everyday data are stealed every day. Okay, and I believe this slide it will be simply mind-blowing. You can type in your search engine world biggest data breaches hacks, and you will get the first link. It's called information are beautiful / world biggest data breaches and hacks. So what is this? This is a reported cases on the timeline grouped by companies, and also grouped by the number of database records actually breached. And you see there's a lot of famous names: Facebook, Marriott Hotels, Twitter, Occidata, Microsoft, Equals. Down below, you see down Uber, Yahoo, and also down there in 2016, 15, 14, there's a winner, epic winner, two times with 1 billion. I will say again, 1 billion records inside. It's Yahoo. So 2 times in history, Yahoo was breached, and it was leaked 1 billion per leak number of records. And again, now when we see Yahoo, Microsoft, Facebook, Ashley Madison, Uber, government institution, Delight, and also we can simply ask the question: why is this possible that this can happen to me? Yes, it is possible. And the most danger part in this situation is when we say to us, it's a false sense of security. When we say to ourselves, this will not happen to me. I am not so interesting. I'm not dealing with that kind of data. Who will blackmail me? And so on and so on and so on. And in one point in time, we are hacked. You are hacked. And that's the point. If you are, if we are not prepared, it can knock down our business, our company, ourselves, really down below. Okay, so what is missing? why this is happening. We can speak, believe me, in next 8 hours. Why is this? And I believe each one of you will give reasonable argument in their opinion that makes sense. This is one of my opinions and my proposals. What we can do in our own environments to make this cyber security story much better than it is now. I believe on other side of this conference, to all of you who are now listening, and you listen maybe later recorded session, that you have some kind of cybersecurity department in your company, and that's cool, that's nice. But is this cybersecurity department funded on the right direction? I will try to explain in next couple of slides. Okay, the first part is threat modeling. The ABC of all security start with the risk. So we can't just jump on web interface and say, okay, I will on this form pay attention on this input. I will take care about that. In DB, I will try to put encryption, or I will try to use SSL. All these arguments make sense, but they are not systematic. They are simply just brainstormed. And that's okay, but in security, this is not so okay. So there is a formal approach. It's called threat modeling. There's a lot of books, blogs, tutorials, how you can do threat modeling. Basically, this is about describing security aspects of our systems. What it means? It means that you will divide your security project, all your sprints, your user stories, every step in mind should be as a security. I simply miss to put one more slide in the presentation, and I apologize for that. It is about agile. I believe many of you using agile in their job, and agile is fine. They're agile from one side and DevOps on the other side. Simply makes things better, faster, and more agile, as the same name. But there is if you look tenant of documents of agile documentation, and if you search. But by Control F in your browser, in your Word, I don't know the tool you're using, if you search for word security, you will get 0 result. I will spell it again, 0 result. No security at all. So security is left behind in agile, and that's the major. I respect agile, but lack of security in that methodology simply produced in last 10 years a lot of data breaches, because programmers simply does not care about security if there is no specific request. So we need to put security back in the process from the analysis and to design, to writing the code, to the deploy, and back on the square one and through iteration. So it will minimize potential cost, minimize need to write code. There's a lot of benefits about this, and the most important part, you will spot this these security potential weak spot in the early beginning phase, not later. For example, one web form, and that web form, for example, has some login data, 2 text boxes, username, password, login, cancel, and I forgot the password. So when you put this form through the threat analysis formal method, the major point of security is SQL injection, that you prevent user to not type SQL code, SQL command through the user interface. And to prevent that, you will need to take care through the different layers of the application, application layer, business logic, user stories, database layer. There's a different layers of your system that you need to take care. The most important part in SQL injection is that you use dynamic SQL, and there is a mitigation techniques. And if you are not using input validation, you will get SQL injection attack. So based on this example, I believe you are getting the picture what is about threat modeling. Now I will leave you simply to think about this process and try to see, is there any chance to think and to implement this kind of technique inside your environments. Okay, and last part of this, what is missing in security story and why security is so bad is simply that the most organization, and that's unfortunately still look on security as non-functional requirements. So I need you when something goes wrong. I need you to implement encryption. I need you to take care about this, but not I need you to take care of security from A until Y to my company in all segments. And that's one of the problems. So you need the SISO, C position inside your company, who will take care or she will take care about security through the policies, strategy, standards, ISO, to simply to create a plan how to integrate and maintain security. Now you need implementation part, operational part, that will actually implement this let's say war plan in security. And these are security specialists. There's a different kind of names, but one of the mostly used are security specialists. So application security, system security, network security, and so on. And also you need an ethical hacker. So you need a person that will try on the ethical way to break down security inside your company. And in this part, we are jumping and we are speaking about red team and blue team. I believe that if you put on the table, let's say 10 companies, maybe, and I say maybe, 1 of 10 have the red team and blue team. What is that? Red team is one number of people, let's say 5, let's say 2, and their major goal is to break the security inside the company in all aspects. Application, network, system. They will simply try to knock the company out, but in an ethical way, because these are our boys and girls. So they will explain to us, we are finding and we are fine these exploits, and we need to fix it. And also the blue team is let's say good guys that actually try to prevent red team to hack the company. So basically, it's a struggle. It's a fight. It's a good fight between inside the company, inside our own people to defend offensive and defensive security, but in not on destructive way. And the final part is when the breach is happened, when something goes wrong, when security incident as a lower level and the breach as a higher level shows up, the team needs to jump in and simply execute the steps A, B, C, D, F, D, G, and so on. And if you don't have the incident team, response team, you are stuck with security inside the company, which they are blaming themselves. You are guilty, I am guilty, you are not guilty, who will do that? And that's a scenario that you can afford to your company, especially in that case. So you need to have the team, drill team, simply will jump to start to fix the situation. depends on the size of the company, depends on the business, depends on the actually business plan. You will need to inside this couple of bullet points to say I need this or I don't need this. But you need the SISO, you need the plan, and you need at least one ethical hacker who actually try to break through. Okay, now we are jumping in the concrete part. Handle data with care. And this part of presentation is simply tied to SQL Server, because if I want to be more concrete, I need to stack to one DB platform. If I try to be more general, to cover SQL, Postgre, MySQL, MariaDB, Oracle, I don't know, then I will say a lot, but I will say in essence nothing. So I will try to be more specific, more concrete, but because of that, I need to use one platform as a role model. Okay, database server security model. I believe all of you here are at least familiar with one or not or all items on this slide. So database as a server and database as a data collection as an instance on server gives you a different spectrum of security items to tune, to configure. Everything starts with the login. So the login is the first part of authentication. Who am I? Okay, that's the one question. Who are you? I am Jasmin. But second part of the question, are you really Jasmin? And that's the most important part. Everyone can lose the credentials. You can be hacked. You can be sniffed. You can be simple target of the attack, and that your credentials are leaked out. You are not aware of it, and someone is using, I don't know, to access your resource, and you simply don't know that. And that's that part. Are you really that person? And that's that section where I would just mention 2FA, two-factor authentication. So I'm Jasmin. Yes, this is challenge. I give you a request. I giving you a number. I giving you one more factor and give me a response. And that response is mostly one-time password. And that password or that token will be never reused again. So really enforce the freshness and will enforce this application part. On truth layer, we are speaking about authorization. Okay, what are you can do inside my system? Read, write, modify, delete, and so on. And this part of authorization are going in two directions: server side permissions and database side permission. And we are going to the column level. So SQL Server can give you out of the box on the click permissions to the column level with some kind of command with SQL Server 2017 and 19. We are speaking about row level security. When you can say, okay, first 5 records you can read, next 5 you can write, and until end you can do anything. Simply you don't see them. It is not out of the box. And when I say out of the box, I mean you can simply click it. So you need to type command. So yes, in a nutshell, it's inside the engine. You can use it, but it requires more SQL skill set to implement a row level security. But you can go easily to the column level security. Okay. Also, when you install your DB engine in cloud, on premise, on hybrid solution, you name it, there is a couple of steps during and after installation. If you leave them like that, and if you don't pay attention good enough, you can create endpoints that can malicious attacker can use and reuse to do some malicious steps. I will go off topics for 10 seconds. There was a cases I saw them in my career. In in last 10 years, where the attacker was inside the system for years, for months, until they are spotted, and they are mostly spotted on their way out, because when they are leaving the environment, it was really hard to clear all traces of activity. So the alarm is turned on that situation, but it's too late. So and all of these situations are generated because the persons or IT teams does not pay attention, especially in this steps during and after installation. So SQL Server example is simple, is childish, but look, I believe that where is the problem? When the team create the software, write the code, they are doing that in staging on farms, on testing environments, and so on. And in that environments, they have almost by default full access. In most cases, we are speaking about SA account, SA, so server administrator. So if you have source control, and if that code goes on stage and go on production, it can easily goes out with SA account or SA password hard coded inside your connection strings, and I see it a lot. Also, the protocols. For example, depends on the SQL Server version. When I say version, I mean standard, enterprise, developer, workgroup, web, and so on. Different set of protocols are turned off by default. And see this, share memory, name, pipes, and TCP/IP enabled. Why? Why I need all three of them? I need, for example, only TCP/IP. Disable any attack surface as possible. Turn it off, delete it. Simple. You need to be gone, because if you leave share memory and name pipes and you never use it, you will forget on it, and someone will scan your network and try, and they will find it. These protocols, they are by default, and they are in. Believe me, they are in. And also the third part, in installation part, and it's mostly tied by database, is about user password. If you use SQL Server Authentication, please enforce password policy. Please enforce password expiration policy, and please enforce that user must change password on next login when you create password for them. Yes, I know it's painful with the forwards. It's boring to change. Who will remember password with 16 characters, 12 characters, special sign, and so on? But without these steps, any sniffing attack will sniff the hashes of password, and it can be easily brought and hacked to the modern GPU cards, server farms, and so on. Also, the part that most of us are simply ignore, and we are speaking about threats of unauthorized users. What it means? The users inside our companies. So we are buying the firewalls, application firewalls, and so on to defend ourselves outside. But what if threats goes inside? And there is a number of cases where employees, because reasons A, B, C, D, name it, simply they are trying to do some activity that is a gray zone between a regular job or malicious job to give the data to third party, to make the benefits, to blackmail, because they hate you, because they lose the job. So there's a different set of activities where these users can try to exploit, and that's why in last year, and especially last year in this COVID-19 situation, one security model simple jumps in. It's called zero trust. Zero trust, I don't trust nobody. So I treat you inside my environment same as outside. So you need to pass to rigorous authorization section each time. Yes, I know implementation is kind of expensive. It takes time. It takes expertise. But zero trust model is something that we need today, especially now when we are working from homes. For example, this conference now is virtual. I am not in your country. I'm not in your time zone. I'm thousand miles away. And for example, that we are now in same network and my PC is compromised. It means that from my PC, attackers can compromise entire network of that company. So VPNs, 2FA, SSL, HTTPS, and all this story needs to be forced in this zero trust model. Okay, so the user role simple is not enough. So I'll just go back. So if your environment is based on just a role, I will give you read, I will give you write, or I will give you deny on some reasons. That means your security and privacy is not good enough. So this is the story. So I will give you select on I don't know DB with 50 tables. It means you can read 50 tables with your select statement. So what is the problem? The problem, I can read all of them. So I can write the statement and to see salaries, to see reviews, to see I don't know, patients' records, students' grades. It depends on the system, and I can use and reuse that information ethically or not ethically. So company is now based, and it depends on my ethical principles. So mitigation is this scenario is also not enough, but it is something based. If you're using this is simply not good enough. But if you try to do this, you will mitigate situation, and you will make it harder to users with permissions to break through in private and more secure part of the system. So give access, deny, use store procedures, use views to map tables, deny ad hoc queries, and use encryption. I will speak encryption more later in presentation, and that's the most important part in this prevention and mitigation data breach techniques. Okay, physical data stealing. What it means? It means that we are forgetting that inside threats can easily can get data files, backup files, and all other files inside a company. If that user is authorized to copy backups, to create backups, to use company drives, cloud drives, Google, I don't know, Microsoft Office 365, and so on, it means that that user can copy all that on their own PC, remote or not remote. It means that he or she can detach and copy that files. So you have the potential breach. And I will leave you to think about this part. Part two is outside of DB. So yes, I'm DB owner, I can handle data, but outside of DB planet, you are going outside in totally different ecosystem, file system, operating level, network layer, where the other threats simply are waiting to extract your data. So you put your DB on network share, on cloud share. The file system permissions are weak. There's exploit in OS. So there's a numerous reasons where this outside threat can penetrate and exfiltrate this kind of sensitive data. Okay, mitigation. Mitigation of this part is very simple. You need to use encryption. You need to use encryption in all levels: table, column, and entire database. Again, it depends. It depends on your business process. You need to encrypt backups all the time, because the backups are the most weakest part, because they are put aside. They are putting aside backup on off-site location, on primary, secondary, tertiary location. So you have the one backup on 3 locations. Can you guarantee that all these 3 locations are top security? I can't. But if I do the steps and make the backup really hard to penetrate, even if you have the physical access, then it's a whole different story. You need to encrypt the volumes, disk drives, USB partitions with BitLocker, VeraCrypt, and different set of tools. Also, passwords. If you use classic archives, zip, 7-zip, and WinRAR, please use password, because these archives using also encryption. Limit the number of admin staff. If you have 25 admins inside your administration, you have the 25 problems. So you need to have really small number of admin staff with high level privileges. Also, the really important part is audit. If you don't have audit, if you don't who, what, and when is using, copying, modifying your data, and if breach is occurred, and if incident is occurred, you will really have a really difficult time to point the finger and say you are guilty. In almost every case, you will just say we are the breach, we are down, sorry, we will try our best, but you will never find who is doing it. But if you implement audit in all levels, and this is totally different presentation, I will simply don't have time to go deep down, but application level, web server, FTP server, DB, and even when you log, you need to make that logs are tamper-proof, because the person with most right to access to that logs can modify the logs, so can falsify them. So you need to make the tamper-proof mechanism inside your logs. And now concrete SQL Server. SQL Server has a state-of-the-art encryption mechanisms. So everything starts on the operating system level. What it means? It means when you install SQL Server, Windows Data Protection API creates service master key. Service master key is IS-256 encrypted, and it's guarded inside the master DB. Each new database will have its own database master key, and that database master key is encrypted, guarded with service master key. So it means if you need to decrypt and encrypt DB, you will need this service master key. And now inside DB, you can create the whole tree, all the leaves of the certificates, encryption keys, symmetric, asymmetric, to encrypt the concrete data inside your DB, and each of them can be fail safe of one below. So, for example, if this symmetric key is used to encrypt column, for example, credit card number inside the bank customers table, if you use this key, that key is guarded with a symmetric key, and it is guarded with the DB master key, and it's guarded by service master key. So attacker needs to have 1, 2, 3, 4 keys and know to passwords to unlock the keys. If attackers have all four keys, it means it has the physical access to server, or the server is on location where attacker can simply goes and copy all these key. On the application level, I can get one key But if I just pull out this key inside his comfort zone, that key is totally useless without this all these three keys below above him. So this hierarchy simplified simply ensure that keys are secure enough in these situations. And these are the algorithms that SQL Server can use to encrypt the DB and data. This triple key simply ignore it. It's obsolete, and from SQL Server 2016 it simply is not supported. So if you use it because this, try to change it and avoid it, because triple is simple is not secure enough. So if you need to use something, use AES and use AES 256, simple as that. And if you are speaking about asymmetric algorithm, there is RSA. Again, the longest key is more secure, but longest key indeed it means it will be slower. So how much slower? It depends on your CPU power, it depends on your network, it depends on your client. So you need to test it to trade the pros and cons, to say, okay, I will use this and I will use that. And now it's a balance about security and performance. Okay, and this example of one column, first name, I will show you later in a live demo, where symmetric key is used to encrypt first name inside the database. Always is a really cool feature. Always encrypted eliminate the DBA from equation. What it means? It means that always one person, and it's a DBA, have access to server, have access to all key, and have access to data. So you can't simply create enough good wall to defend data from DBA. So how we can eliminate DBA from security equation? If we use always encrypted, and this encryption pulls out encryption and decryption story on client side. So, for example, DB is with data on server, and data are encrypted. So table customers is encrypted. So I will say subject name from customers, where parameter at SSL is equal to that. So this is the user input here. Now this input goes to A2.NET, and A2.NET use the key to encrypt the input. So input looks now like this: 0x7ff654a6d ciphertext. So SQL Server say, give me the name of customer where SSN is equal to this string. Because this string is inside the DB, it will results set, create a result set, and send back to the client. The results came to A2.NET library, trust boundary zone. It will be decrypted and say the name is Wayne Jefferson. So encryption and decryption and key management is pulled out from server to client side. So we now need to handle security on client side, but we are eliminate this high privileged user from this story. But okay, this story has also its own side effect. So what's the side effect? There's two types of encryption that you can use in this case scenario. If you use randomized encryption, it means each time will create different encryption string of the same plain text. So 1, 2, 3 to 9. It will create one time like this, next time like that, second time like this again, and so on. So each time it creates different ciphertext. So yes, you will be secure, but you can't do any functional operation on your data. So like comparisons, summarizing, and so on, it will be useless. because each time same data looks different, and it's more secure. But if you use a different approach, so when each same string each time is encrypted on the same manner, so 1 to 9 each time will be same, so you can use like operator because each time you compare with the same string. So basically this case scenario, so this query works fine because Wayne Jefferson each time is encrypted. Because this SSN ID is always encrypted on the same way. So each time, if you're using as a primary key or foreign key, you will have same result, and that result can be used with query to create and/or operation, comparison, very close, join, distinction, rule by, and so on. So it's more flexible, but it's less secure. So attacker can sniff the network, extract the data, and through the time he or she or group can find the pattern in some data, and maybe can decrypt that string and actually to see what we are talking about in our so-called encrypted communication. Okay, before the move, if you don't have the money, for example, because encryption is kind of still expensive sport, but it's becoming cheaper and cheaper. You can use to defend your backups, your archives with, for example, 7-zip. 7-zip is open source. It's free, and use AES-256. It's a military grade encryption to defend your archive. So there is no difference at all if you encrypt backup on SQL Server with AES-256 and you create the backup and encrypt the 7-zip. You will get same level of protection. What is an issue? Issue is a key management. Who will handle the keys? Who will have the password? So in 7-zip story, you will be more exposed. In SQL Server story, you are not so exposed. So it's again balanced, but it's better than nothing. Okay, now I will show you a short demo before I finish my session about how to encrypt the data on SQL Server environment in couple of comments. Okay, I will now create quickly DB and jump in, and I will create a database master key. And this database master key is guarded by service master key. And if I query this Symmetric keys system view, I will see that this is my key that I created before a couple of seconds ago. You'll see it's AES-256, created, modified it, and some other metadata important to understand what is going on under the hood. Okay, I will now to create some test environment, some hypothetical encrypted customer table with some set of columns, and I will create certificate. So I will create the same scenario as slide before. So DB master key, certificate, and the symmetric key, and that key will be used to encrypt the concrete data. So certificate will be used to defend the key. Certificate is defended by master key. So 3 levels of protection so far, and I will now finally create AES key. Just to see if someone write to me, or is everything? We are fine. Okay, nobody say anything. And now I will open the key in memory. I'll open key in memory. Okay, and I will now create a subquery to insert the customer data from Adventure DB and encrypt that data by key GUI customer SIM key created in a couple of steps before and imported in my new table. So it's simple query, nearly 20,000 records. Okay, you'll see this is a laptop. So it simply import 20,000 rows and encrypted some of them in no time. So in no time, It's actually 1 second, one second on laptop. Now I will close the key, so it will be flushed out from memory. And if I try to see data inside the table, I see last name, credit card. You see, they are all encrypted. So this is the data which attacker can see if he or she get the DB. So if data which occur, this is a mitigation, prevention and mitigation. So prevention that customer data is not used and exposed in deep web. Mitigation techniques is in this phase. Simply, I will try to minimize damage if damage occurs. So if I try to see data again, so again, I will open the key, and I will show you side by side customer ID, last name, encrypted form and unencrypted form. You see, this is Sanchez in clear text and Sanchez and Duffy and Welters, Erickson, and so on in encrypted way. Okay, I will now go back in my presentation. So I'm here to finish my presentation. It's 4 minutes until end. So thank you for your attention. About me, almost 20 years. I am professor at the university, and also I'm SISO in one company, and also for 11 years I am Microsoft MVP. But this is not so important. The important part is that I try to share my experience, to pass my knowledge free of charge through the conference, through the books, and through all my services. Maybe you noted on the first slide, at Jasmin Azemovic is my handle on Twitter, GitHub, LinkedIn, where you can find a lot of stuff that I actually share with community on data, cybersecurity, privacy, and digital forensics. And one of that resource that actually I share is this book. So you can all of you can now go on GitHub, type my name, and you will see some of repositories down there, and you can download this book free of charge with these examples and many more of them clearly explained how to implement security on SQL Server. Yes, it's 2012, but most of the features are simply the same in now 7 years later. And yes, keep calm while we steal your data. Thank you. Thank you all, and I'll go back on Teams, and I will now turn my camera on to see me, and I will try to see to answer the questions if you have them. Thank you.
Sure. Thanks, Jasmin, for the lovely session. So I don't see any questions published in the Q&A section. So thanks again for joining in and making this event a good one. Thank you. Thanks a lot.
Okay, thank you for picking me up, and I will try, and I hope this session will be useful for some of the people who actually see it later. Thank you.
Definitely. Thanks, Jasmin. Hi, Rob. Rob, are you able to hear me?
I am. Are you able to hear me?
Yeah, I'm able to hear you. How about you? How are you?
I'm doing well. How are you?
I'm doing great. So we have a couple of more minutes, 1 more minute to go live. So can you please share your deck so that I can add it into the live?
Definitely. This presentation has no slides, so let me share my screen.
Sure. We can see a screen.
You can?
Yeah, I can see a screen.
Perfect.
So let's give it a minute and we'll get started.
Okay.
Okay, we'll get started now. Thanks. Hi everyone. So the next speaker from our conference is Rob Richardson. He'll be presenting content on Docker for Windows Developer. So Rob, first of all, welcome to the Light Up virtual conference, and thanks for taking out your time for this noble cause. So the stage is all yours. Please. Go ahead, Rob. Thank you.
Most definitely. Thanks for the introduction. This is going to be really, really fun. This is a no slides demo, so this is literally my only slide. You can find me, Rob Richardson. Tweet me at rob_rich, and you can find the code that we're about to build on robrich.org. So let's head to robrich.org. I'll click on presentations, and here is Docker for the Windows developer, and you can click on this GitHub repo right here, which will get you to the code that we're about to build. So, right now it's a smidge stale because it's the last time I did it, but that's totally cool. While you're here, click on About Me, and you'll see a little bit more about things that I've done. I'm a Microsoft MVP. I'm a friend of Redgate. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. Next time you're in Phoenix, join us for the next AZ GiveCamp. Or if you'd like a GiveCamp in your area, reach out to me on Twitter or by email, and let's get philanthropy installed in your area as well. Some of the other things that I've done, SQL Source Control Basics. I was on the Gulp Core Contributors team in version 2 and version 3. One of the things I'm particularly proud of is I replied to a .NET Rocks podcast episode. They read my comment on the air. They sent me a mug. Woohoo! So there's my claim to fame, my .NET Rocks trophy. Just kidding. So let's dig in. We want to build a Windows product using containers. So I've got Docker Desktop installed. I'm going to make sure that I switch into Windows containers, and let's create a new project. Here's a new project. I'm going to choose a web application. And in this particular case, I'll choose a .NET Framework application because we're on Windows containers. Let's pretend this is, I don't know, legacy Windows app. Here's an empty folder. And so let's put this here. We'll call the solution Net Framework, and we'll put it there. Okay, Net Framework 4.8. That's perfect. Yeah, let's build an MVC application. So now we have our application. Now, a typical Windows application will probably have a website, and we may have a backend service as well. So once this spins up, let's also go build a backend service. Installing NuGet packages is fun. Okay, so we've got Visual Studio fired up. Let's add a new project, add new project, and this one will be a Windows service. Now I did need to install the desktop workload for this to get the service to show up. Yep, Windows Service 1, that's perfect. Now we have our, for lack of a better term, our our legacy app. It does all the things that we want it to do. Here in this service, we may have a task. Let's, I don't know, delete this initialized service and the designer. We probably don't need that, but we want our application to do something. So let's say using system.timers, we'll create a timer, private read-only timer. Timer, and we'll set this timer equals new timer, and we will give it an interval of, I don't know, 1 second. Let's say enabled is false, and let's give it a callback. So timer.elapsed. Create that method. Oh, that's perfect. So every time the timer elapses, we can get it to go do the work. In this case, console.writeLine, let's say service doing work, and we'll give it date time.now.to long time string. So now our service is doing work. This is perfect. Now, right now it's set to enabled false, and it's enabled false on purpose because once the service starts, then it'll do it. So timer.enabled equals true on service start. Timer.enabled equals false on service stop. Okay, so now we have a website, we have a Windows service. This kind of matches what we expect. Let's see if we can put this in containers. One of the rules of containers is that it will run one and only one process, exactly one process. Right now, this service is built to start up like, well, a service, a background process. And we probably want to flip that over to be more the command that our Docker file will run. So let's do that. Instead of descending from service base, let's just say service. Now we don't have this override, so let's just say public void on start and public void on stop. Here in our program.cs, we can't do all of this service base run thing. So var service equals new service 1, and then service.start. And we need to pass in a new string array because, well, that was the arguments there. In time, we might choose to remove that. And then we need to get something to keep this process alive so that Docker knows that it's still running. So while true thread.sleep 1000, we could output something like still running or whatever, but yeah, that gets it done. We've now converted our process, our service, to a console app. We might choose to come in here to the properties and flip it from a service to a console application. We may choose not to. It works either way. But now we've got our application that is going to run with a single thread on the primary process. So let's Dockerize it. First thing we need to do is we need to add a Docker ignore file. Let's add a new item. This item will be a text file. And this text file will be .dockerignore. And that is important that it is .dockerignore and not dockerignore.txt. Not that unlike a git ignore file, this then lists all the things that we don't want to copy into our container. Bin, obj, star.user, star.suo, the .vs folder. We might include other things, star.log, anything that we don't want to move into the container. With that Docker ignore file set, let's go build a Docker file. Now again, we're going to create a new item. This will be a text file and it will be Docker file. Now again, it's important that this is Docker file and not dockerfile.txt, because this will be the definition for Docker that describes how we build this process. We can come in here to the properties, and for both the, I lost it. Oh, it renamed it dockerfile.txt. Let's rename that back to Dockerfile. Yes. Okay, so here in our Docker file, we'll say from. Now we're going to stand on the shoulders of giants, so let's create a base container that is that Docker file. So I'm going to head over to Docker Hub. Browser. There we go. I'm going to head over to Docker Hub and hub.docker.com, and I'm going to type in .NET Framework. As I hit .NET Framework, I land on this page that shows me the various repositories for interesting things. So samples is really cool. That has lots of different Docker files that I can use. Runtime, ASP.NET, SDK. Well, I'm going to build in this container, so let's open up the SDK one. So the .NET Framework SDK tells me that I need to Docker pull this container name. And now this is for 4.8. So, and my application is on .NET Framework 4.8. That'll be perfect. So from Microsoft. Okay. So now the next thing is we need to copy in everything from our current directory outside the container into the current directory inside the container. Now this first directory outside the container is wherever we run the Docker build command. This one inside the directory, let's set that. Workdir to, I don't know, let's make up a directory, src. Perfect. So we've copied it in everything, and then let's run ms build. And we'll say something like net framework.sln/p configuration equals release and /m, so it'll run on as many cores as we have. Perfect. We've just built this solution. Well, before we do that, we need to run NuGet restore so that it can restore all the NuGet packages. Well, right now, if we make any code changes, it will copy this layer in, then it will NuGet restore, and then it will build. We probably want to include our NuGet packages in an earlier version, so let's move that up here. But now we do need to copy in net framework.sln into the current directory. We need to copy web application 1.csproj into the web application 1.csproj. So we're just copying that file into place. Let's do a similar thing for the Windows Service one. And then we also need this packages.config. So let's go grab packages.config. That tells us what content we need to copy into place, or what NuGet packages we need to restore. Okay, so we've copied in all of our manifest. We run NuGet restore. Then we're going to copy in everything else except for those things excluded from the Docker file, and then run the build. Next, we would probably do something like run nunit.exe. We don't have any tests in this project, but that's okay. And then we'll do something like, let's copy the results. That's going to be in /src/ Windows Service 1 /bin /release into the current directory. What is the new current directory? Workdir is, let's call it app. And then the thing that will launch as the container starts up will be Windows Service 1.exe. Perfect. Now, if we were going to do nothing else to this Docker file, that would be completely sufficient. This does all of the pieces associated with our application, but right now we're deploying our source code as part of our build. So let's do that a little bit differently. Let's come back over here. We'll come here and we'll look at, oh, the .NET Framework runtime. That's perfect. Here's the .NET Framework runtime, and it specifies a different container. It's only slightly different. This one says .NET Framework SDK, and this one says .NET Framework runtime. So we've got the .NET Framework runtime. That's perfect. We copy in all the things, but we're no longer copying it from our host directory. Let's copy this from equals build. Well, where is that build container? Well, let's tag this one as build. What that says then is this is my build server, for lack of a better term, and this is my production container. Here's my production container down here. So I'm building two separate containers. I'm going to throw away this top one as soon as I'm done. That's totally fine. But then I've got this bottom one that only has the runtime and my built executable. That's perfect. So let's fire up a command inside this directory. Hey, give me my machine back. Windows is going to take a nap. Okay. cd desktop, cd docker, cd net framework. Okay. We want to docker build. We're going to pass in the build file, which is Windows Service 1 Docker file. And we want to build out of the current directory, so the last dot. That will be our outside directory. Here's that process where we go build it. Now, it's going to do all of the processes associated with a build server. It's going to do copy in all of our content. Here's that NuGet restore. Then it will do a build. We've commented out our tests, but it could definitely run all of our tests and ultimately produce the final result. While that's building, let's go craft the content for this other piece. Nope, it's not going to let me. There we go. So we want to do a similar thing here. We're going to add a Docker ignore, a new item. This will be a text file. And this text file is a Docker ignore file. It's definitely not a docker ignore.txt. Bin obj star.user star.suo .vs. We also probably want to exclude in here the properties, not properties. Yeah, we'll come back to that one. Okay, and then a new Docker file. This will add a new item. This one will be a text file, and this will be Docker file. Now we want it to be Docker file, not dockerfile.txt, and it did it again. So let's rename that, and we'll take off the .txt. Yes. Now this Docker file got us really close, so let's copy that and we'll paste it into place and we'll get it started. All of the build process is great. We do want to do one more thing here though. We want to publish the web application. So let's publish this web application.csproj/configuration equals release, deploy on build, publish profile is folder profile. Okay, so how do we build that folder profile? Well, let's go in here and we'll say publish. Now I could choose to publish to Azure, I could choose to publish to, but let's choose to publish to a folder. That's perfect. That folder, bin app publish, that's fine. We just need to know where it is. And now I've got this folder profile. Back in our Docker file, let's look at this. And so instead of copying this, we'll copy web application 1, and then we'll go into bin app publish. So that's all the content that we want to copy into the current directory. We're not using this, we're using ASP.NET, and this will actually go to inetpub www root. Now the CMD actually comes in from the base container. It's IIS, and now we've got a second container ready to go. Let's take a look at this build and see how that worked. That was great, it built just fine. Docker run that container. There we go. Docker run that container. And now I'm able to, let's see if we can hide this actually. Nope. The system cannot find the file specified. That is interesting. Docker run dash IT that container. And let's see if we can go find out what that was. Ooh, it looks like we have a build failure. Build succeeded. I'm guessing I forgot to save. Let's go check. Here in this Docker file, Windows Service 1 bin release. Windows Service 1 bin release. Nope, I think that might be good. Let's save all just in case. Save all. And let's go build that other container. So Docker build -f web application 1 / Docker file, and we'll build out of the current directory. This will go build the website. So now we're doing a similar process. Now we noticed that, oh, it didn't. We may get cached results here where we don't need to restore all the NuGet packages if we're just spinning up another web application. Because we haven't changed our code, the next time we build, all of these new packages that we're restoring right now will already be cached in Docker and will be ready to go. So we've restored some NuGet packages. It's going to copy in the rest of our application. We're running MS build. I really wish Teams would let me hide this. We've got our build succeeded. We're running the web application publish. We published our website. Copied it into the new container, and we're ready to go. Docker run. Now here, when we run this, can I move that? Nope. Docker run, we're going to want to pass some additional arguments because we don't just want to run. We want to, hey, give me back my command. We want to also forward some ports in. So let's forward in port 8080 to the containers port 80. We're going to go across the Docker network switch, and then we'll build this, or we'll run this, the thing that we just built. So it's going to spin up that website. It'll actually spin up IIS inside the container. And now if we go to our browser and go to localhost. Now it's not actually localhost, it's running inside the container, but through the magic of Docker, it will automatically forward it off into the container, and that will work just fine. It may take a smidge to spin up this website, but that's totally fine. We're getting that IIS spinning up. The JIT compilation, there is our website. We got our service into a Docker container. We got our website into a Docker container. And that Docker file, there was really only 4 verbs that we really needed to worry about. From, where we talk about the base container that we're building from. Copy, where we're copying content into the container. Run, where we're running batch commands, batch file or PowerShell commands, whatever we'd like to do to be able to accomplish tasks inside the container. And then CMD that specifies the runtime piece, the thing that will kick off and do all the things. There are other pieces that we definitely could set inside here, but that's the majority of the pieces. So we've got that Docker container ready to go. We'll just leave it going. Docker image or Docker container list, and we'll see there's that container running. Let's grab that container ID and we can say Docker logs that container ID, and that will show us all the console output. In this case, there isn't any. That's totally fine. Docker inspect that container, and we can see all the particulars associated with that container. That's pretty cool. We'll leave that running, Docker container list. And let's step back here and we'll switch from .NET Framework to .NET Core. So .NET Framework is really cool, and that's fun to be able to build .NET Framework apps, to be able to move them into containers, and we saw how easy that was. Let's build an ASP.core web application. Web application 1, we'll give it a solution name of .NET Core. We'll make this MVC app. And now right here, we can see that there's this enable Docker support button. That's really cool. Let's leverage that going forward. So if we were to create a greenfield app, we could automatically get Docker support into our application. Now it does ask us to pick whether we're on Windows or Linux so that it can scaffold out the correct Docker file for us. Let's create that application. And similarly, we're going to want to create a Windows service. Now in .NET Core, new in .NET Core 3, we have a worker service template. Now this worker service allows us to do all the things that we did with a Windows service, but in this case, it's cross-platform. So it works on Mac and Linux just as well as it works on Windows. Here's that enable Docker support button, and so we'll leave that one checked. And now as we see the application spin up, not only do we already have our Docker file, we already have a Docker ignore file that is really interesting as well. In both projects, a Docker file and a Docker ignore file. Let's pop open that Docker file. Now this Docker file, I would argue, is a bit more complex than it needs to be, but we can see all of those same principles that we saw in there. We start with a base container, .NET Core, SDK 3.1, Nano Server 1903. If we wanted to, we could switch this up to 2004. We're going to copy in all of our manifest details, and then we'll run .NET build. We'll do a publish, and then copy in our final results so that we can kick that off into a website. That's perfect. Similarly, in our worker service, we do a similar thing where we copy in all the pieces. We're going to do a build, we're going to do a publish, and then we'll be able to run that worker service. Now, the one thing that we do want to do here with this worker service, here's this service that program.cs will start up, not that unlike a website where it builds in dependency injection, our inversion of control container, our IOC container, and it launches then this worker. Now we could add more workers if we want to, but here's that worker class, and it does all the pieces of, while we're not stopping, let's wait, and then it does some work. Hey, this worker service is running at this particular time. That's perfect. It's doing all the work that we need to. Now there's one more thing that we can do here. Here in .NET Core, because those Docker files are built completely for us, which is really neat, let's create a new file called a Docker compose file, dockercompose.yaml. Now this YAML file will allow us to specify all of the pieces of our application. Let's add an existing item into our solution. We'll go pick that dockercompose.yaml because it applies to both pieces. Version is 3.1, services. We're going to have a website and we'll have a service. In both of them, we'll say, I would like you to build. The context is the current directory. So, that's where we start building. And then the Docker file is web application 1/Docker file. That'll be the same mechanism that we'll do in the Windows service, but here it is worker service 1/Docker file. In the build, we also, during our run process, we wanted to expose a port. So let's say ports, and we want to say, I don't know, 8080 is already taken. So let's go to 8000. We'll redirect to port 80. And we can specify other environment variables to say, you know, here's the environment variable that I want to set to this particular value. In this case, we don't need any, so we'll just leave that blank. Now this Docker compose file then specifies all of the Docker build commands and all of the Docker run commands that we need to be able to launch this application. Let's do that. Net core Docker compose up. Now Docker compose up will notice that we haven't built these yet, and so it'll build both of them, both the website and the service. So here's that first stop. It will go do all the things. Oh, it noticed that I had built them previously and it just launched them. Here's our worker service doing all of the pieces. It's launching and running. We can then go to localhost 1000 and we get our .NET Core website. Our .NET Framework website is still running just fine. We are still running that container, but now we're also running this .NET Core website in a separate container. We didn't need to provision IIS. We didn't need to spin up any hardware. We didn't need to install Windows. All of that is handled by the container infrastructure for us. We created this one configuration as code file, and we were able to launch it into place. Well, now why would I do this instead of Kubernetes? Well, the cool thing about Kubernetes is Kubernetes begins with, so you have a Docker file, so you have a Docker container. And so we created this Docker file, we built this Docker container, and now when I'm ready to launch it on Kubernetes, I hand the same image to my Kubernetes cluster, and away we go. So for example, here inside Docker Desktop, if I go into Settings, I chose previously to, where is it? I chose previously to launch Kubernetes. Oh, we're in Windows mode. And so Kubernetes is already running in my Linux side of this container. Well, we've got these containers running. Let's say Docker compose down, and that will take care of removing all of these containers, destroying all of that hardware. We didn't need to, I don't know, salvage all the things. We didn't need to unplug wires. If we now refresh these, we'll see that neither of them is running anymore. They are completely, the Windows service, the .NET Core Windows service is done. Let's go look for Docker container list. We see that we still have these other ones, so let's remove these. Docker container rm-f, that one. Docker container rm-f. Let's go turn off this one. Docker container rm-f. Let's kill this one. Docker container rm-f. And let's go kill this one. So we've now removed all of the containers that we spun up today. Well, that's cool. Now, what if I want to run this content on Linux? How do I get it from here to Linux? So I'm going to click on here and I'm going to say switch to Linux containers. If I switch to Linux containers, it'll say, hey, that'll take a minute. That's totally fine. Let's switch. Switching into Linux containers, I have that same Docker daemon running. I have that same ability to spin up containers, but now I'm running inside this really lightweight Linux virtual machine. In this case, I'm choosing to use WSL. So if I say WSL-list-v, I'll see that it's actually running inside this Ubuntu Linux virtual machine. Now I don't need to worry about that virtual machine at all. It completely takes care of it. Now, what do I need to do for my Docker file? Well, the only thing in our Docker file that is Windows specific here is this reference to Nano Server. If we were to use just ASP.NET 3.1, it would work identically. Or we could use Alpine, which is a really, really lightweight Linux distribution. Let's switch both of those to Alpine. We'll also switch both of them here to Alpine. And now I'm doing the exact same process, Docker compose up. And now here in Linux, it will go see if my containers exist. If they don't, it will rebuild them. And now we just spun up our thing. Here's our worker service that is running. Here's our website that's launched. And so now if I go refresh this localhost 8000, we see here's our ASP.NET Core website running inside of a Linux container. That's really cool. We were able to get an application running, both a legacy .NET Framework app and a brand new greenfield .NET Core app running inside Docker with not a whole lot of fuss. We just needed to work on those 4 containers, and now we can take that and launch it into Kubernetes. I have Kubernetes running here in Docker Desktop. So if I go into my settings, I'll see that Docker, nope, not Docker Engine. Here's Kubernetes. I enabled Kubernetes mode. So technically, these containers are already running on Kubernetes, and it shims that Docker compose syntax into Kubernetes. I could now choose to publish these to Azure, to an Azure Container Registry, or I could do other mechanisms to get that content up into Azure or any Docker runtime to be able to use that there. So we saw how easy it was to build out a Docker file. We saw how powerful that was to be able to spin up hardware on demand. That was really cool. You'll find this code on robrich.org after this session. What are your questions?
Rob, I see one question which was there earlier. It said, is this a .NET framework or .NET Core that was used?
Good question. Our first example specifically was .NET Framework. Our second example was .NET Core, so we did one of each.
Okay. I hope this answers the question from a user. So that should be it. We don't have any other questions, Rob.
Wonderful. Some people ask me sometimes, let's go back to this other solution. I'm going to save that and go back to the .NET Framework version, but this same syntax applies. Some people ask me, why are we copying in all of the things? Couldn't we just copy them in all together and move this NuGet restore back down here? Would that work? Yes, it definitely would. And it would, but it's a little bit less efficient. Now, if I change any of my C# files, I'll need to restore my NuGet packages. By copying in our manifest first, all of our CS_proj details, and then running NuGet restore, then copying all the other things, we can usually get a great speed up of build. So if we were to change one of these CS files, now the build could start here and use these as cache layers, which is really, really effective. Similarly, they're like, well, why are we doing all of this process with 2 containers? Could we just do it like this? Yeah, most definitely, that would work as well. The container image will be slightly bigger that way because I'm deploying not only the build tools, but also my source code into my production container. All else being equal, I really like lighter containers. So I'm going to spin up this second container that allows me to get only the pieces that I've built into place. So simultaneously, a similar question around this realm is, well, couldn't I just build inside Visual Studio and then copy this from my local directory, say, /bin/release into place, and then ignore all of this part? Well, we could, And that would definitely be an acceptable solution. At this point, we're not building inside the Docker container. We're building on our local machine and copying the results into the container. That would work as well. The downside to this approach, though, is we're removing that build in a neutral environment. Now we're getting the code that is on your machine. We're not doing all of the standard validation. We're not restoring the NuGet packages specific to the build system. So by having this build server, for lack of a better term, this build container that allows us to build in a neutral environment, we still get all of the benefits of a CI system. We get build in a neutral environment. We get to restore the latest versions of all the packages on our build server. We get to ensure that we only produce content if our unit tests pass, and all of those steps associated with building inside of a container. So then another question that we often get is, well, if I'm building inside of a container, do I still need a DevOps pipeline? Yes. In your DevOps pipeline, run that Docker build command, put that up to your container registry, and that ensures that the container is built in a completely neutral environment and matches your corporate policy about pull requests and auditing and all the other things. You probably don't want to Docker build from your local machine and publish it up to your production server. So these are some of the frequent questions. Are there other questions that users had as we wandered through this?
We don't see any questions right now, but I mean, since we still have time, everyone please feel free to put your questions in the Q&A section so that Rob can go ahead and answer it.
And as you're typing those questions, if you find that you want to reference this code, you can grab this straight off of GitHub. I'll push publish shortly after we hang up here. And if you find a question tomorrow, tweet me at rob_rich, and we can definitely continue this conversation. Either pulling in content into Docker and using that in Docker Swarm, or building these images and publishing them to Kubernetes. I can definitely help you with that as we get closer to.
We don't see any questions coming up yet, so let's give us a little bit of more time to see if we get some questions, Rob.
Okay, perfect. While we're there, I'll flip over to .NET Core. And let's see if we can clean up this Docker file a bit. Oh, that was an interesting error. It said my container is configured as Linux, but I've configured my application as Windows. There was one more piece that I needed to do in here. Default target OS, Linux. Let's do that in both places. So we really like that really simple container. Nuke all the comments. This is as base. Microsoft uses this mechanism inside Visual Studio to allow us to debug the container, and that is really, really interesting. But it does make the container a little bit more cloudy. We're exposing the two ports, 80 and 443. But here, let's do this. Let's copy in our manifest. So we'll copy in netcore.sln. We'll copy in web application 1.csproj into the web application 1 folder. Copy in worker. Did we have another question?
No, Rob.
Okay.
Let me check. Yeah, we have one question. The question
perfect.
Is it more expensive to host a Windows container than a Linux container?
That is a great question. Comparing Windows and Linux containers. If we're running .NET Core we have the ability to host in either. We can run in Linux containers or we can run in Windows containers. Generally, the Windows-based containers get to be pretty large. In .NET Core, we can run off of Nano Server, which is significantly less than other pieces. But Linux will be significantly less, will be even more or less, even smaller. That's a better way to say it. So in Linux, the Alpine container image is around 50 megs. The Nano Server one is 500 megs. The bummer part is as we get to .NET Framework can't run on Nano Server because Nano Server is 64-bit only and has no GUI pieces. In spite of the fact that in our website and in our Windows service, we weren't using any, GUI things, part of the .NET Framework is system.drawing, and system.drawing depends on GDI+, and GDI+ is a GUI component. So therefore, .NET Framework can't run on Nano Server. Because of that, for .NET Framework apps, we must depend on Windows Server Core. And Windows Server Core comes in at about 5 or 8 gigs. So 50 megs for a Linux container, 500 megs for a Nano Server, and now we're up to 5 gigs. That's big. Now, on the upside, once we get that image cached on our machine, on each production runtime machine and on our development machine, we don't need to pull that 5 gigs again every time. But it is large. So all else being equal, if we have the choice, I would prefer to run on Linux containers, but we have to first get from .NET Framework to .NET Core to be able to do that. Linux containers are generally lighter weight, and that just makes everything easier. That was a great question. So here we've done some interesting things with this Docker file to make it a little bit easier to see. We still have our base because, yeah, Microsoft needs it. But now we have a much clearer path to what we expect. Here's our build server, and it's doing the same processes, copying in all of our manifests, doing our .NET restore. Now, in this case, I chose to copy in all of the other projects as well in case I have some class libraries that have some dependencies that we need. But then ultimately copy in everything else and build, publish, and then copy from that publish directory those things that we need into place and launch our application. All else being equal, that Docker file might be a little bit simpler to understand.
Yeah, we still have not received any new questions, Rob. So okay. Let's see. I mean, we still have like 12 minutes pending. So let's see if anybody comes up with the question by then.
Okay. One of the questions I often get here is, how do I integrate my unit tests into this process? How do I get my tests to run? And the cool part, we've just refactored this Docker file to be a whole lot simpler. Here's our build server, for lack of a better term. And we've just built everything. Here we can run .NET test. Now in this case, we don't have any test projects. So of course this is going to fail. So I'm just going to comment it out right now. But that's how we would run unit tests. And the beauty there is because we've got all of our tests running right in this step right here, we know by the time we get to this step right here, by the time we get to that publish step, all of our tests have passed. If at any time our tests fail, Docker build will stop here, and we won't get this final container built at all. So we add this .NET test piece, and we may need to then copy the contents of our run SCP, our test results, to some network drive, or perhaps we need to publish them through our build system in interesting ways. Some suggest that these could be great as build artifacts. I've also seen mechanisms where they map in volumes so that they can dump their build results into place. But that's the mechanism of how we get our build results then into our build server. One of the things that I really hope comes across in this is how easy it was to get started. There's only those 4 Docker verbs, and once we understand those, we can pretty much take any application, any .NET application, and get it into Docker. That was really fun. We got to get both a .NET Framework and a .NET Core app into place in a half hour. If I can do it in a half an hour, you can definitely move your application into Docker as well. One of the questions I often get is about licensing. Like, how do I license this? How do I license Windows? How do I license any DLLs that my application may choose to use? Now, the cool part is that when you license Windows, you're licensing the Windows kernel, the Windows operating system. And in a container, you don't have the Windows operating system. It's sharing that Windows operating system with the host machine. So you can run any number of containers without another license of Windows. Now, probably in your web server of choice, your ISP, they have Windows Data Center Edition that gives them the ability to host any number of virtual machines, and that license is completely sufficient for all of your containers. If you're licensing your components, Telerate components or Component 1 components or similar things, they like to sometimes license based on installs. And the bummer part is I am installing them every time I build. So to that end, you may run through your installs really fast. Work with your vendor to find a better way to license that component, or a site license, or most of them have gotten on board to understand that that license key that's used inside the container will work just fine. So they're not counting the number of times that you've installed it. They understand that in containerized environments, then it'll work really, really well. If you must get it licensed just so, then oftentimes there's a registry key or a license file that you need to copy into place as well. And once you copy that license file, then everything starts to work just fine. But that is one place where you may want to shy away from containers, where you have to very specifically license specific components registered in a very careful way. I would also argue it might be time to move on from that vendor. What other questions do we have?